June 2021, variant 62. So here we go. Let's read the first question completely and then decide the name of the topic. In a game, a ball is thrown and lands in one of the four slots labeled A, B, C, and D. The person wishes to test whether the probability that the ball will land in slot A is 1/4. There are four options available, and 1/4 is the probability for each. State null and alternative hypothesis. Second part, the ball is thrown 100 times and it lands in slot A 15 times. Use a suitable approximating distribution. That means you should justify the use of this approximation and carry out the hypothesis test at the 2% significance level. So this is question number 1 and this is for 6 marks. First of all, what is the question all about? The question is about hypothesis test. And what is the distribution that you see? It's a binomial probability distribution. And what will it become? We will see in a short while. So first of all, H naught is the symbol for null hypothesis. So therefore, probability of success is 1/4. H1, alternative hypothesis, probability of success is not equal to 1/4. Why is it a two-tailed test? Because clear cut, they have not said it would either be more or less. So that's why whenever there is ambiguity, whenever there is uncertainty, whenever you have a difficulty in making a decision, so therefore it's a two-tailed test. The ball is thrown 100 times. So now you would write the distribution. X follows a binomial distribution 100, 0.25. So n is 100. Probability of success is 0.25. Probability of failure is 0.75. There are three calculations that you do. The first one is NP, that is 100 into 0.25, that is 25. The second one is NQ, that is 100 into 0.75, which is 75. And the third one is NPQ, which is 100 into 0.25 into 0.75. So for the last one, I need to grab my calculator, and this comes out to be 75 over 4, which let me get it correct. So that is 75 divided by 4, and this comes out to be 18.75. Now, first of all, what does each of the value mean? This thing is expectation of x, this means nothing, and this is variance of x. These are the formulas for binomial distributions expectation and binomial distributions variance. First, justify. Justification is, since NP is greater than 5 and NQ is greater than 5, therefore X now follows a normal distribution, approximately normal, that is 25, 18.75. That's the first thing. Now, since it's a two-tailed test, the first thing is that this 2% is divided into 1% each. And secondly, more than that, what is the direction in which you will be calculating the probability? So now the thing is, the sample value, have they given us the sample value? Yes, that is 15. Sample value is 15. Sample value is lesser than expectation of x. So therefore, focus on lower tail. That means this sample value by default is inclusive. Calculate the probability x is lesser than or equal to 15. Don't forget continuity correction. So draw a number line. Let me make it less thicker. So something like this. And this 15 is over here, and 15.5 is the upper class boundary. 14.5 is the lower class boundary. There are two options. This is option 1. The red is the option 1 and the purple one is the option 2. Since 15 is included, let me draw this line a little bit bigger. Since 15 is included, so therefore after continuity correction, this becomes probability x is less than or equal to 15.5. Why do we need the inequality? Because so that we have the right continuity correction. We don't actually have to find the probability, we just have to convert it into the z value. So therefore probability z is lesser than or equal to 15.5 minus 25 divided by square root of 18.75. Probability z is less than or equal to. So when you use the calculator and then you simplify, this comes out to be negative 2.194. So negative 2.194, and just stop over here. Draw a normal distribution curve, and on it, what do you label? You label the lower tail and the upper tail. So this is 1%. This is 1% because 2% was the overall. This z value is 2.326. This z value is 2.326. Let me double check from the syllabus. So this is the normal distribution table and 99% value is 2.326. So this is all good, all set. 2% was divided equally. 2.19 negative, this is negative, and 2.19 lies outside of the critical region. Since calculated z value lies outside of critical region, therefore do not reject H naught, therefore accept H naught. Therefore, what is the status quo? The status quo, things as it is, was that K, the probability that it will land on slot A is 1/4. So insufficient evidence to accept Raju's claim, that is one thing, and insufficient evidence to prove that probability of landing in slot A is not 1/4, it is something else. So that's how you do a question of hypothesis test, and in this one it was the first question that we got started with. So 1 plus 5 is 6 marks for this one. Now let's move to the second question. It says the random variable x has the distribution such and such. So now we have something to do with binomial, and then they're asking for variance and approximating distribution and then some probability. So this is a question that is a binomial distribution becoming a Poisson. So that is the first thing that we see. So now the very first thing is justify the use of this approximation. That is the first thing. But initially it's binomial. So variance of x, that is equals to NPQ. And also one more thing, that is the concept of linear combination. Variance of x is NPQ, that is 400 into 0.01 into 0.99. Because n is 400, probability of success is 1%, probability of failure is 99%. So now when I do the calculation and when I multiply it, what do I get? So after multiplication, this comes out to be 3.96. So let me just hold it at one place, and this comes out to be 3.96. Now what is the rule? From linear combination, variance of ax plus b is a squared times variance of x plus variance of a constant. Variance of a constant is 0. Keep that in mind. So therefore, when I do this, variance of 4x plus 2, that is 4 squared times variance of x, that is 16 multiplied by 3.96, and that multiplies and gives us the answer 63 3.36. So that is the answer for this part. Now comes the approximation. State an approximate distribution for x. Now you have to exactly justify it. Giving the values of any parameters, justify your choice of approximation, and this is for 2 marks. So now let's rewrite it again. X follows a binomial distribution 400, 0.01. Calculate NP, that is 400 into 1 over 100. That comes out to be 4. Now what is the justification? Since n is greater than or equal to 50 and np is lesser than 5, therefore x follows a binomial becomes a Poisson distribution with 4. That is the justification, that is the working. So the litmus test is this value of np. If np were to be greater than 5 and nq would be greater than 5, then binomial would actually become normal, as in this particular question. Now what does it say? Use your approximating distribution to find probability x between 2 and 5. So now it's a Poisson question. X follows a Poisson distribution with 4. Probability x lies between 2 and 5 inclusive. Therefore, there are 3 terms that you need to calculate. E raised to power of minus 4, 4 square over 2 factorial, 4 power 3 over 3 factorial, 4 power 4 over 4 factorial, and it's between you and the calculator. Take care of the accuracy and then finally give the final answer correct to 3 significant figures. So now this question is done and it's still 5, my bad. So I need to calculate one more term, that is 4 power 5 over 5 factorial. So now based upon this, what I would suggest is that it's always wiser to draw a number line so that you don't forget nothing. So therefore you write 0 and 1 and 2 and 3 and 4 and 5, and the numbers that you're interested in is 2, 3, 4 and 5, 2, 3, 4, 5, and then you do the calculation and you get all the answers. Let's look at question number 3. Right from the start, you know what it is about. This is a question of CRV, continuous random variable, and the emphasis is very much on a graph and interpretation of the graph, something to do with symmetry, coordinate geometry, and so on. The random variable x takes the values in the range 1 to p. So the lower limit is 1, the upper limit is p. The graph of PDF is shown in the diagram. The p is over here. The base is p minus 1. The height is p. The area of the triangle is half into p minus 1. And this area should equal to 1 because that's the sum of all the probabilities. So show that p is equals to 2. So first multiply, that is p square minus p is equals to 2. That is cross multiplication. P square minus p minus 2 equals to 0. P square negative 2p plus p negative 2 equals to 0. P minus 2 plus 1 p minus 2 equals to 0. Therefore p is negative 1. Therefore p is positive 2. This p is negative 1 is rejected because the graph is so obvious, and p is equals to 2 is accepted, and that is what the answer says. Calculate expectation of x. So now first thing, coordinate geometry. Value of p is 2 and you see this line. So therefore let's find the gradient of this line. So p is 2, one point, that is 1 comma 0. The other point is p comma p, so that is 2 comma 2. Find the gradient, that is 0 minus 2 over 1 minus 2. That is negative 2 over negative 1, which is positive 2. And double check, the diagram also states the truth. Y is equals to mx plus c, and y is, just plug in any value. I think let me plug in 2. So this is 2, m is 2, x is 2, and c. So 2 minus 4, that is negative 2. Therefore, y is equals to 2x minus 2. That is the function. So now the function, the PDF, is basically, if I want to write in the proper format, that is 2x minus 2, and it exists between the limits 1 and 2. So x lies between 1 and 2, or 0 otherwise. The function does not exist elsewhere. So what is the expectation of x? Expectation of x is integrate between the limits 1 and 2, and don't forget to multiply by x, the original function, which is 2x minus 2 dx. First multiply, then integrate. So limits are still intact. 2x square minus 2x between the limits 0 and 2, 1 and 2. That is 2x cube over 3 minus 2x square over 2 between the limits 1 and 2. And then you would simplify, and something minus something, and that will be the value of expectation of x. So that is question number 3, the two parts. This is 2 and 5, that is 7 marks. Now we are on question number 4. So now what is question number 4 all about? Question number 4 is all about, seems like, linear combo. Linear combination of random variables. These variables could be just like that. It could be Poisson. It could be normal. So this is normal. So this is linear combination of normal variables. Now the question says, this person, Wendy, a journey to work consists of 3 parts. There is a walk, there is a ride, and there is a walk to the office. So I would say the first one is a train, and the other one is walking, it's riding on the train, walking to the train station, riding on the train station, and then walking to the office. So there are 3 parts. The first one is normal distribution. So you write the n outside and then the bracket, 15.0, 1.1 square, and then the next one 32.0 and 3.5 square, and the last one is the office thing, that is 8.6 and 1.2 square. Now remember, these values are mean and these values are variance. Find the mean and variance for the total time for Wendy's journey. So let W is T plus R plus O. So W still follows a normal distribution, that is 15 plus 32 plus 8.6. And similarly, the variances is 1.1 square and 3.5 square and 1.2 square. So now add it all up, and what do you get? You get 55.6 and 14.9. So that is 55.6 and 14.9. That is the answer for this part. Now it says, if Wendy's journey takes more than 60 minutes, she is late for work. Find the probability that on a randomly chosen day, Wendy will be late for work. So this is the statement that you need to highlight. If Wendy's journey takes more than 60 minutes, she is late, and we are looking for late. So probability W is greater than 60. Probability Z is greater than 60 minus 55.6 divided by 14.9 square root. And let's simplify the numbers. This comes out to be 1.140. So the Z value, not the answer. Probability Z is greater than 1.140. Now over here, this knowledge of S1 normal distribution is used. So probability Z greater than a positive value is 1 minus probability Z lesser than a positive value. And then you go to the table, and then you read off the value, and then you subtract. So what do you get? You get the answer as 0.127. So that is the final answer, correct to 3 significant figures. And of course, we all are aware of the normal distribution table. That is over here. So something like 1.140. So this is 1.1 and 4 and 0. So this is something like this, 1.14. And this was the value, and then you subtract, and that is what you get. So now it says, find the probability that the mean of Wendy's journey time over 15 randomly chosen days. Now, first of all, what are they asking? Probability, mean of Wendy's journey times over 15 randomly chosen days will be lesser than 54.5 minutes. Now, this time, the question is about 55.6 and 14.9. So, first of all, W follows normal distribution 55.6 and 14.9. But this question is about sample mean. So, when it's about sample mean, you put a bar, you divide the variance by the number of sample, which is 15, and then you calculate probability W bar is greater than 54.5. That is probability Z is greater than 54.5 minus 55.6 divided by square root of 14.9 divided by 50. So this is the concept that you apply in this particular question, and this comes out to be negative 1.104. So probability Z is greater than negative 1.104, and this thing is less than. So my bad, this thing is less. So this is less and this is less and this is less, less. Z lesser than a negative value is the same thing as probability Z greater than a positive value. So that is 1 minus phi. Phi is another way of reading from the table, another symbol, 1.104. You go to the table, you do the subtraction, take care of the accuracy, and the final answer is 0.135, correct to 3 significant figures. So that was a straightforward question of linear combo. 4 questions are down. 5th question. It says the time. So let me grab this thing first. And it says the time spent by customers at a particular gym has a distribution such and such. In the past, the value of mu has been 42.4. Following the installation of some new equipment, the management wishes to test whether the value of mu has changed. So has it changed for the better or for the worse? We don't know. It has changed, so it looks like a two-tailed test. And secondly, what else are they asking for? They are asking for the mean time for a sample of 20 customers. Let me underline, that's the mean time. Sample of 20 is found to be 45.6 minutes. Test at the 2.5% significance level whether the value of mu has changed. So now this is strange that the first question was also about a two-tailed test, and the second is also about a two-tailed test. So let's get started. And this is hypothesis test. Actually, yes, this is type 1 definition wise, and then hypothesis test, and this is for a normal distribution. Now, first of all, what is meant by type 1 error in the context of this question? So now this is important, type 1 error, and in this context. First of all, write the textbook definition. What is the textbook definition? The textbook definition of type 1 is reject H naught when H naught is true. Now, when H naught is true, that means, first of all, let me write down what is H naught and what is H1. So, H naught, mu equals to 42.4, H1, mu does not equal to 42.4. So, H naught is true. That means the value of mu is 42.4. But we are rejecting H naught. In other words, we are accepting H1. In other words, we are accepting that the mu value does not equal to 42.4. Now join both parts together. And how do you read it? I'll say, even though the mu, what is mu? Mu is the time spent in gym. So the time spent in gym is still 42.4 minutes. That's the average time. But who is the person? Management. So, but the management insist that it has changed. Now that's the thing. This is, we are talking about an error that is happening. So therefore, we are concluding that the mean time has changed, whereas in reality it has not changed. So this is the definition of type 1 error. Now it says we have to calculate the 2.5% significance level, and that's two-tail test. So first of all, let me draw a normal distribution curve. So this is normal distribution, and 2.5% is split equally. So this is 1.25%, and over here this is also 1.25%. So now this z value is basically for 100 minus 1.25%. That is how much? That is 99 and 98.75%. So let me go to the table. 9875. So if I highlight 9875, okay, that's a nice number, and this is what you get, 9875, and the z value is 2.2, and this thing is 4. So that is 2.24. So coming back to this, the z value from the table is for 98.75% is 2.24. So this is 2.24. This is negative 2.24. Now let's go with the calculation. Now the calculation is, first of all, W T bar, so, or X bar follows a normal distribution. This is 42.4 and the variance is 38.2. That is 38.2. And since it's a bar and we are dividing it by 20, the sample mean is 45.6 minutes, and it's a two-tail test. So since the sample value is greater than the expected value, that is the mean, so we would be focusing on the upper tail. Just calculate the z value. That is 45.6 minus 42.4 divided by 38.2 over 20 square root. And let me grab my calculator and then do the necessary calculation. So this comes out to be 2.315. So that is 2.315. Now, does this value lie in the critical region? So let me denote it with a green marker. Does this value lie in the critical region? The answer is yes. Z calculated value lies in critical region, therefore reject H0, therefore accept H1. Therefore, yes, we have sufficient evidence to accept the management's suspicion or the management's claim that the mean time has changed. Is this thing correct? So now this is question number 5. We are done with this. Let's move to question number 6. What does it say? It says the heights of a random sample of 100 fully grown animals of a certain species were measured. So it's time to give it a name. And n is this, and sigma h is this, and sigma h square is this. Find unbiased estimate of population mean and variance. And then it says calculate a 99% confidence interval for the mean height of the species. And then something else is also there. Now, first of all, this is a question about unbiased estimates, and it's a question about confidence interval for population mean. Now, first of all, what we do is that all this data is from a sample. So X bar or H bar. So H bar is sigma H over N. That is 7570 over 100. That is 75.7. And similarly, variance for the sample, that is sigma H square over N minus H bar square. Therefore, this is 588050. 588,050 over 100 minus the exact value 75.7 square, and you get some answer. First of all, unbiased estimate of population mean is the same thing as sample mean. An unbiased estimate of population variance, it's n over n minus 1 sample variance. That is 100 over 99 into this value that's at the top. And then you use a calculator, and then what do you get? So you get this answer as 151.525. 151.525. And of course, this is for calculation purposes. For this part, this comes out to be 152, correct to 3 significant figures. But if I use it in the other parts, okay, so you have to use this value for other calculation. So this looks like either. So for other calculations, this is what we will use. Now again, like before, I'm emphasizing this fact that there is another formula that is also there. It's your choice which one you like to use. So this is 1 over n minus 1 sigma x square minus sigma x square over n. So let me write it down, or you can see it for yourself. So I'm not using this. I'm so much used to that. So if you want, you can use this formula also for calculate unbiased estimate directly. So now this thing is done. Calculate a 99% confidence interval. So the formula is x bar plus minus z sigma over root n. First of all, 99% means 99% in the middle. So z value is for 99.5. I remember it. This is 2.576. X bar, you already calculated it. I think that is 75.7. Sigma would be square root of 151.525. Use the 4 SF value minimum. N is 100. And then when you do this calculation, this is 75.7 plus minus 2.576. Value of sigma is 151.525 divided by sigma square root of 100. And then the final answer is 72.5 and 78.9. That is the lower limit and the upper limit of this confidence interval. Now, what is this question all about? Now, remember the phrase that is used a lot. That is, knowledge of S1 is assumed. It says 4 random samples were taken and a 99% confidence interval for the population mean was found from each sample. So now 4 random samples were taken. Find the probability that all 4 of these confidence interval contain the true value of mu. What does it mean? It means that contains the value of mu. That means this. So this is your probability of success. So first of all, you would write x follows a binomial distribution. 4 comma confidence interval is you are calculating on this percentage. So that is your probability of success, all 4 of them. So probability x is equals to 4, that is 4C4. Success raised to power of 4 and failure raised to power of 0, which comes out to be 0.99 raised to power of 4. Now someone could ask this question, is it necessary to use binomial? The answer is no. This is basically the concept of tree diagram, and then you can say success and success multiplied by itself 4 times, and this is 0.99 raised to power of 4. So this is perfectly right. But what if the scenario changes and they would say exactly 1? So I'm writing C star my question. Find the probability that exactly 1 of these 4 confidence interval contain the true value of mu. If this was asked, what happens? You would say x follows a binomial distribution 4 comma 0.99, and now you have to use binomial 4C1 and success raised to power of 1 and failure raised to power of 3 and then this is 4 into 0.01 cube into 0.99, and that would be the answer. So that is why this knowledge is a must. Question number 7. What is this all about? Customers arrive at a particular shop at random times. It has been found that the mean number of customers who arrive during a 5-minute interval is 2.1. So right from the beginning, you would have a sense of it that this is a question of Poisson distribution. So this is the ratio that they are working with. Find the probability exactly 4 customers arrive during a 10-minute interval. So this is time, and this is number of customers. So in a 5-minute interval, you have 2.1. In a 10-minute interval, you have x. So this is common sense. This is a basic ratio. So that comes out to be 4.2. Therefore, x follows a Poisson distribution with 4.2. Exactly 4 customers. Probability x is equals to 4. That is e raised to power of negative 4.2. 4.2 raised to power of 4 over 4 factorial, and that is the answer for exactly 4. Now, what else are they asking? They are asking find the probability at least 4 customers arrive during a 20-minute interval. So 5-minute is 2.1 customer, 20-minute is W customers. So multiply by 4, so W comes out to be 8.4. So W follows a Poisson distribution with 8.4, at least 4. So probability W is greater than or equal to 4. That's 4, 5, 6 all the way till infinity. That is 1 minus probability W is less than or equal to 3. So therefore this is 1 minus e raised to power of negative 8.4. The mean has changed, and this is 1 plus 8.4 plus 8.4 square over 2 factorial and 8.4 cube over 3 factorial, and everything is taken care of. So now you would use a calculator, do the subtraction, take care of the accuracy, and then you get this answer. So this is question number 7, the second part. The third part. Use a suitable approximating distribution. Find the probability that fewer than 40 customers, so this is fewer than 40, 40 is not included, arrive during a 2-hour interval. So time customers, 5 customers in 2.1 minutes. And now this is a 2-hour interval. So 2 into 60 is 120. And we are dealing with a value, let's call it M. So 5 multiplied by 20, 24. So basically M is 24 into 2.1. That is 48 and 2.4. That comes out to be 50.4. So if I'm not mistaken, this is the correct value. So you would say since lambda is greater than 15, so therefore M follows a normal distribution 50.4, 50.4. Why? Because expectation of x is lambda, so is the variance of x. That's the property of Poisson distribution. Now it says fewer than 40. So probability M is lesser than 40. What needs to be done? Continuity correction. So this is 40, this is 40.5, this is 39.5. 2 options are available. This is option 1 and this one is option 2. Since 40 is not included, so therefore the correct option that we need to use is 39.5. So therefore your working is probability M is lesser than, let me choose the other marker. So probability M is lesser than 39.5. Tell to the examiner that you have done continuity correction. Probability Z is lesser than 39.5 minus 50.4 and divided by square root of 50.4, and knowledge of S1 is assumed. Probability S is lesser than, after you do the simplification, that is negative 1.535. So now what should be done? Flip the inequality, remove the negative sign, greater than 1.535, and that is 1 minus phi of 1.535. You go to the table, you get the probability, take care of the accuracy, subtract it from 1. So therefore, there are two possible answers given, 0.0624 or 0.0623, and examiner has marked both of them correct. So that completes May-June 2021 variant 62 of the S2 paper, which is paper number 6. Stay tuned for more.